Okay, pre-calc fans, today we're looking at sketching polynomials. So some stuff that we have to remember from last year when you did this in Algebra 2. Okay, all even degrees with a positive lead coefficient. Okay, those look like this. Think about a parabola. Parabolas are this. Remember, y equals x squared are these things. Okay, so that means they go high to high. Okay, so what I do is I mean, it's like high to high, meaning as you read from left to right, curve starts like this, it does its business in the middle, and then it finishes high. You know, so it could be a fourth degree equation, does little squiggles in the middle. It could be a sixth degree equation, does squiggles in the middle. So high to high for a positive lead coefficient with an even degree. Okay, an odd degree would be linear, so y equals x looks like that. As you read from left to right, notice it starts low, finishes high. Okay, so it goes low to high. And so we start low, have a little curve, does its squiggles in the middle, and then it finishes high. Okay? Okay. Now some unique pictures. If you see something like this, like quantity squared, like x plus 3 quantity squared, so you have a factor that's being squared, that is what we call a bounce. So if you're looking at an axis, so that looks like this. It looks like a bounce. I call it a bounce. Okay? Like you're bouncing the basketball off your head. Okay? If it says cube, so a factor that's being cubed, it's actually what's called, I call it a drag through. So it looks like this. Comes up, drags through, and then finishes on. So that's where your root would be. So if you are looking at it on an axis, and let's say the point that we're going to drag through is right there, it would look like this. We'd come up, approach, stretch it out, and then finish it high. Okay? So that would be like when you have a cube, when you have a factor being cubed, I call it a drag through. Okay? Okay. All right, now, so let's actually look at some graphs. Last year you guys didn't do this. You saw these. You saw the bounces. Okay? But you did have to know these pictures here. Okay? All right, now, let's look at how I have this written out over here. So here's my first equation. Notice I put them in factored form. We have to know what the degree is. Remember, the degree is the largest exponent after you multiply all your x's together. So this is an x times x squared. So that's a fourth degree equation. Also notice the lead coefficient here is positive 1. You have a positive 1 here in front. So this is going to go high to high. Okay, so this goes high to high. So high to high. Okay, so that's because it's a lead positive and it's a degree 4. Remember the roots, another word for your roots are your x-intercepts or the zeros. And when we're talking about the x-intercepts, that's y is equal to 0 to find the x-intercepts. So you put your 0 there, and then you're literally just saying, okay, what are the roots? So you have -2 as a root, we have a 3 as a root, and then we have -1 showing twice. I'm writing it twice to remind myself that I have to showing twice, I have to bounce there. Okay? So now I'm going to get those points plotted. So 1, 2. When you guys are doing your sketches at home, make sure you, when you draw your axes, at least put some lines on there and mark your points. So here's -2. Here's -1. And 1, 2, 3, there is 3. That's all I'm asking you to do. You don't have to put grid lines, or you don't have to put this on a piece of graph paper. These are called sketches for a reason. All right, now the y-intercept. In order to find the y-intercept, you have to remember, in order to find the y-intercept, x has to equal 0. So literally plug in zeros for all of your x's. So 0 plus 2 times a 0 minus 3 times a 0 minus 1 squared. And you have to crunch this out to get the y-intercept. So 2 times -3 times -1 squared. -1 squared is 1. So we're looking at -6 for a y-intercept. Okay. And now we got to plot y-intercept -6. That looks close enough to me, -6. All right, now we're ready to do the sketch. We already said degree 4, high to high. High to high means we start high and we finish high. Obviously, we're going to start left of -2 at a high spot. And we do our squiggly in the middles, and we finish right of 3 in a high location. That's it. Everything else is just connecting dots. So I'm going to come down here. So I'm going to come down here, hit my -2. I only go through it once. It's not a drag through. I go through it. And now I have to turn back around and go hit -1. Don't make a sharp turn. You make it curvy. And you bounce at -1. And now we have to go hit our -6. And then we go, now we have to go hit 3. And we finish high. Okay. Yes, there could be more stuff going on between -6 and 3, that it could go down a little bit. But this is why it's called a sketch. This is a rough idea of what the graph looks like. If we wanted a perfect graph, then we would just type it into the graphing calculator and say, "Ooh, there it is." Okay. That's why these are just rough sketches. Very rough sketches. And you're plotting out the important points. Your intercepts, all of your intercepts, your x-intercepts and your y-intercepts. That's all you're looking for in a rough sketch. All right, let's look at another one. So up here, yes, there's a lead coefficient that's negative. No big deal. We don't care about this. It doesn't affect the degree. It doesn't affect the roots. It will only affect the y-intercept. All right, so degree. There's no x here to worry about. X squared times an x to the power of 3 is x to the power of 5. Okay? The lead is negative. The lead is negative, so what does that do to a normal curve? Okay? Remember, the directions here are low to high for a positive lead coefficient. So then what would happen with a negative lead coefficient? That's right, we would go high to low for a negative. So this negative right here says your picture is flipped over the x-axis. So if we're flipping over the x-axis, starting low means we start high. Finishing high means we finish low. So this negative right there says we are going, so this negative right here, the -3, says we are going high to low because of the negative sign. And it's a 5th degree. All right, the roots. Again, the roots, that means your x-intercepts, that's y is equal to 0. Plug in 0 there. You don't care about -3. There's no x attached to it, or it's not saying x minus 3. So that doesn't even exist in our world when we talk about the intercept, the roots, the x-intercept. And so we have -4 that shows twice. And we have and you have +1 that shows 3 times. So this is that drag through. This is a bounce. Okay? So no bouncing the ball off your head, and this is a drag through. All right, now the y-intercept. So again, the y-intercept, we're going to say x equals 0. And so I'm going to plug in 0 for my x's. Don't lose the -3. So then it's 0 plus 4 squared times 0 minus 1 raised to the power of 3. All right, so 4 squared is 16. -1 when you raise it to the power of 3 is still -1. And then you're just multiplying all these things together. So negative times negative is +3 times 16 is 48. So we have a y-intercept of 48. So I just got to go plot all this information. So 1, 2, 3, 4 looks good to me. Then you have 48 up here somewhere. And then we have 1. I'm going to put 1 right there for my drag through. There we go. And remember what I said. This is a negative lead. So a 5th degree is backwards, upside down, so we go high to low. So I start high, and we finish down here low. And then we just got to connect all the dots. So in order to, we go, once we hit the -4, we can't go through it because our next spot of hitting is 48, the y-intercept. You're forced to bounce the ball off your head. Okay, then let's go hit 48. You know, yes, you can go up and squiggle or go straight across. I don't care. That's what a graphing calculator is for. And now we have to do a drag through. So a drag through would mean you start like this, drag through, come down to the other side. And there, look at that. Looks perfect. Okay, so you don't go straight through. You sort of come down to the left of it, drag through, stretch it out, and then come down. That's what I mean by a drag through. There, I just sketched this equation. Okay, so these two spots would look okay. The 48, I mean, it could go up high, then hit the 48, or it could go straight to the 48 and then go up higher, then come down, but that's what your sketches are. This is just a rough sketch. We don't know exactly what happens around the y-intercept, but we do know what happens here, and we do know what happens here. All right, let's look at number 3. All right, notice I didn't put any directions here. We're still doing the sketch, so what's the first thing that we have to know? That's right, you have to know what the degree is. And what's our degree? That's right, x to the power of 3. Ah, look at this one. I wrote this out a little bit different. You're going to have to think about this one. I don't want you to hurt yourself. Okay, now we got to do our x-intercept, also known as the roots. So when we're doing the x-intercept, that's right, y is equal to 0. So right there, that's a 0. I don't care about the 1/2. It has no effect on the x-intercept. So we have a 0. Uh-oh, what are you going to do about that? Hopefully you're smarter than the average bear. That's right, you have to finish this. Is that x squared minus 8 factorable? No, it's not. So x squared minus 8 equals 0. And what can we do? That's right, add the 8. And then square, and when you take the square root, what do you have to remember? That's right, plus and minus square root of 8. Now, believe it or not, you don't have to clean this up. If you want to clean it up to 2 radical 2, you can. I'll let you think about how I came up with 2 radical 2. The important thing is we need to know what this is as a decimal point. Okay, and you have a scientific calculator, your graphing calculator, type it into the calculator. I know it's less than 3. Well, the reason why I know it's less than 3 because it's in between the perfect square of 4 and the perfect square of 9. So we're at like 2.7-ish or so. And if you're not sure, that's what you have a calculator for. Pull out the old handy-dandy calculator. Square root of 8, 2.8. So we have plus and minus of 2.8. Okay, also known as the square root of 8. Ish. All right, now, so we got that taken care of. So now we need the y-intercept. And our y-intercept, remember, x equals 0. So that means we're going to plug in 0 for all those x's. So we have, don't lose the 1/2. Then you have times 0. Then you have 0 squared minus 8. Well, I don't care about anything here. It's 0 times this junk. It equals 0. So we have 0. Then we have a positive 2.8. So over, that looks like 2.8 to me. And there's a negative 2.8. And now, yes, this is positive. So this goes, starts low, does its squiggles, finishes high. So yeah, a third degree with a lead positive is low to high. So we start low, do our squiggles, finish high. So, and again, we just go straight through. It's not a drag through. You go straight through, turn the corner, go through the 0, turn the corner, hit the negative 2.8, and finish high. We just did our sketches. Okay? I'll let you digest that, pause the video, do what you need to do. All right, last thing that we're looking at now. Now we're going to write the equations in factored form, knowing our basic info, knowing our roots and the y-intercept. Okay? So this is how we start. We start by looking at the roots. We worry about the roots first. So if the root is negative 4, we write it in factored form. The root is negative 4, the factor becomes x plus 4. So that's the first thing, and then this becomes x plus 1. But notice this x plus 1, that's right, there's a bounce there. Remember, you're bouncing the ball off your head, so that means it's going to be squared. So we're going to have an x plus 1 squared. That's the basic right there. Now, I have to worry about the y-intercept. The y-intercept in the picture is 2, and if I plug in zeros here, I'm not going to get a 2. All right, so this is what we do. There's a form that we're going to do here. And because it says write the equation, make sure it says y equals, or pick your favorite letter, f of x, g of x, whatever. All right, so I'm going to use y equals. So y equals some blank space, and then here's your basics of the roots. The only reason I put this little box here, because this is the value that we have to put in. This is the coefficient that we have to have that will guarantee us a positive lead coefficient or a negative lead coefficient. Also, we have to guarantee that we're going to have a y-intercept of 2. Okay? Right now, according to this picture, the y-intercept is 2. And so what happens now is this. What do I do? So this is what I do. I see in the picture y-intercept of 2. I put that right there in for y. So I put 2 equals box okay. So we have to fill in a box with something to make all of these. We have to make this work, to make the left side and the right side equal to each other. All right, now we got a little bit more work to do here. So we have to remember, how do I find a y? If I have the equation, how do I find the y-intercept? In other words, what's the x value? That's right. In order to find the y-intercept, the x value has to equal 0. So what I'm literally going to do now is plug in 0 for those x's. So I have 2 equals box 0 plus 4, 0 plus 1 squared. Now I have a little equation to solve. And if you want to, yes, put a little k in there. Technically it's k for the constant. We're looking for k. So I have 2 equals k times whatever this is. What do I have here? 4 times 1. Okay. There we go. So 2 equals 4k. So k, what does k equal? That's right, k equals a half. Well, I'm running out of room here. I don't want to interfere with this over here. So I'll finish it up over here. So we have 2 equals 4k, k equals a half. Okay, divide by 4, you get a half. Now we just have to properly write out the equation. So it's y equals 1/2 parentheses x plus 4 times x plus 1 squared. So in other words, all I did was fill in the blank. Okay. And notice, what's your lead term? It's positive. Isn't this a positive, what a positive third degree should look like? Start low, squiggle, finish high? Yes. So I didn't even care that this thing was right side up or upside down because the math will fix any problems. Your algebra solving for k will take care of any issues. All right, let's look at number 2. All right, this is a classic drag through. So that means that factor this root appears 3 times. So this right here is going to be a classic x plus 2 to the power of 3. And then this one is just straight through. So times x minus 3. Guys, the order in which you write these two down does not matter. Okay? So there's our basic right there. Now, so once we fill this box in right here, we're all set with the problem. So that's right, according to the picture, here's your y-intercept. That's the y-intercept. And where do we put the 9? We put it in for the y spot. That's right, I'm going to write 9 equals. I'm going to do this step by step by step. And that, right, what are we going to fill in for the x's? That's right, x equals 0 for the y-intercept. That's right, x equals 0 to find the y-intercept. So I have 9 equals 0 plus 2 to the third, 0 minus 3. And you know what you can also say to yourself, folks? If the y-intercept is 9, the ordered pair is 0, 9. So that goes in the y spot, and x is, so this is your x, and that's your y. Put that in for the y, and you put your 0 in for the x's. That's all you're doing. Same thing right here. 0, 2 is the y-intercept. 0 is the x, 2 is the y. Mr. Prada, you're a genius. Best math teacher ever. All right, so what do we have? Somebody's just got to clean this up. So I'm going to put a k in there for constant repetition. And what do we have here? 2 to the third is 8 times a negative 3 is a negative 24. Okay, and then what does k equal? Well, that's, so no fraction to reduce here, so k equals negative 9 over 24. So now I just got to write it out correctly. Y equals negative 9 over 24, parentheses, x plus 2 to the third times x minus 3. So that is the proper equation for us, for this picture to look something like this, with x-intercepts of negative 2 and 3, and y-intercept of 9. All right, and again, notice, wasn't this graph upside down? Yeah, our algebra did the work for us. So we didn't have to worry about, oh my God, it's negative, I don't know, it's upside down, what do we do? No, the algebra fixes the work. As long as you do this formatting, the algebra takes care of itself. So the lead is negative. The lead is negative. Okay. All right, let's look at the last one now. All right, so we're doing the same steps. We got negative 4 showing once, we have a bounce at 2, and we have going straight through 5. So y equals blank. And then I have my x plus 4 showing once. Then I have x minus 2 showing twice. And we have x minus 5 showing once. Okay, yep, here's your y-intercept. So there's your y-intercept, 0, negative 2 is the y-intercept. So where am I going to put the zeros? That's right, you're going to put the zeros in for the x's, and then negative 2 is the y. I'm going to put the negative 2 in for y. And we're going to fill in that box eventually. So 0 plus 4, 0 minus 2, and then 0 minus 5. That's right, we're finding the k. So I have negative 2 equals k times whatever this mess is. Oh, what do we have? 4 times 4 is 20. Times a negative 5. Wait a minute, 4 times 4 is 16. Yeah, 4 times 4 is 16 times a negative 5 is going to be a negative 80. Okay, and now we divide by negative 80, so k equals, what's that, 1 over 40. All right, 4 times 4 is 16, times the negative 5 is negative 80. There we go, 1 over 40 when it's all said and done. How'd I get that? That's right, I divided by negative 80, so we got 1 over 40. All right, so now I just got to fill it out. Y equals 1 over 40, parentheses, x plus 4 times an x minus 2 squared times an x minus 5. All done. And that is your video. That is your video for graphing the polynomials. Or I should say sketching, because these are very rough sketches.